Let's jump right into this explainer. We're looking at the incredibly high-stakes, rigorous investigation that kicks off the exact second a compromised drug gets pulled from the market. I mean, it's not just about tossing bad pills in the trash. It's a full-on forensic hunt to figure out exactly what went wrong. So, what really happens to a medicine after it's recalled? Well, you've got to think of it almost like a medical crime scene. The recalled drug, that's our primary evidence. And finding the root cause is absolutely crucial for public safety. Literally every single move from here on out is heavily, heavily documented because the decisions made during this process directly impact our health. Okay, phase one, the incident. Assessing the recalled medicine. This is where the investigation really kicks off. Regulators have to immediately assess the risk to patients and come up with a strict game plan. Actually, before anyone even touches a test tube, there's a huge strategic phase. Crucially, regulators don't just start testing blindly. First, they review the exact reason for the recall and the real-world danger it poses to, well, us. They methodically pinpoint the exact dosage forms, strengths, and the specific manufacturers involved. Why? Because they need to build a highly targeted, risk-based attack plan. They aren't just guessing here. And you can't just go grab a bottle off a pharmacy shelf and call it a day. Only trained, authorized personnel are allowed to pull representative samples of the affected batch. They assign these unique ID numbers and secure everything with tamper-evident seals. It's basically the pharmaceutical version of yellow police tape. Oh, and they even hold on to reserve samples, just in case the evidence is ever challenged later on. Right, moving on to phase two, securing the evidence. Transport and custody. Once we have our physical evidence safely sealed up, we hit the next critical step, which is moving the samples without compromising their integrity. Honestly, this is where a lot of investigations could just completely fall apart if they aren't handled with absolute precision. Whether the drug requires a strict cold chain or needs to be kept away from light, moisture, or damage, using strictly validated shipping conditions ensures the sample arrives exactly as it was found. Think about it. Even a few hours of unexpected heat on a delivery tarmac could alter a drug's chemical composition. That would completely ruin the investigation. So every single storage condition and transfer is meticulously tracked. This brings us to a really strict legal standard, the unbreakable chain of custody. It's basically the documented history of possession and control of the sample, from collection all the way through testing to its final disposition. It logs every single handover with names, dates, times, and signatures. Without this airtight chain, any lab result could just be thrown right out and legally challenged. No chain, no proof. Okay, phase three, the interrogation strategy. With the evidence secured and resting safely in the lab, investigators now have to map out a strategy to figure out exactly what went wrong with the medicine. Now, you might assume the manufacturer's original certificate of analysis, or COA, is proof enough. But, you wouldn't grade your own exam, right? While the original batch release results are definitely a helpful baseline, they are never accepted as standalone proof of quality. Absolute public safety demands an unbiased second opinion. So independent laboratory testing is required to objectively verify the product using officially validated methods. And there is a strict hierarchy of rules for selecting the applicable quality standard. The lab first uses the specification approved in the product's marketing authorization dossier. If that's unavailable for some reason, they step down to legally recognized pharmacopoeias, like the USP or BP, which are essentially the official global rulebooks for medicine. And if no monograph exists there, they use the regulator-approved validated manufacturer specification. Labs can't just mix and match criteria. Everything has to be scientifically justified. Depending on the defect, the lab is going to subject the drug to a battery of forensic quality control tests. They might check the identity and assay of the active ingredients, test the dissolution and disintegration rate to see how the pill breaks down, or check for sterility and microbial limits. They also verify packaging and labeling, or go hunting for highly dangerous targeted contaminants like nitrosamines or heavy metals. It is a really thorough process. Which brings us to phase four, the experts, selecting the laboratory. Because the stakes are incredibly high, analyzing this evidence cannot be left to just any facility. Regulators need the absolute best to run these highly sensitive tests. Regulators require the absolute elite here, essentially the special ops of laboratories. They look for ISO 17025 accreditation or use official medicines control laboratories and WHO pre-qualified labs. They need proven experience with that specific dosage form, highly validated equipment, robust quality management, and an airtight system for strict data integrity and confidentiality. Literally zero room for error here. Now, what if a sample has to cross international borders to reach the right lab? That creates a massive logistical hurdle. Investigators have to obtain all the necessary regulatory and customs approvals, use qualified couriers with validated shipping, and drag a mountain of documentation like sampling reports, COAs, and chain of custody forms along with them. And then, of course, they have to confirm the receipt, storage conditions, and integrity upon arrival. It's a huge operation just to ensure the evidence survives the trip scientifically intact. And finally, we arrive at Phase 5, the verdict. Regulatory review. All that analytical data comes back to the regulators for the ultimate decision on the recalled product. The interrogation is complete, and it's time to read the results. So how do they reach the final decision? First, regulators evaluate the analytical results against the approved specification. Then, they determine if the original recall reason is actually confirmed. From there, they conduct a root cause analysis and implement CAPA, corrective and preventive actions, to guarantee it never happens again. And ultimately, they determine the product's disposition, meaning, does the batch face complete destruction, or is a tightly controlled rework permitted? So how do these invisible, rigorous safety systems protect you every time you open a medicine cabinet? Well, this whole process reveals an immense, hidden forensic network working tirelessly behind the scenes to keep us safe. The next time you see a drug recall on the news, you'll know it's not just a product failure, it's the trigger for an uncompromising scientific manhunt. It really makes you wonder, doesn't it? What other invisible safety nets are quietly operating in the background of our daily lives, protecting us without us ever even noticing?